So we're a Seattle-based company. We specialize in what's called productionizing machine learning and AI. Clearly not on using PowerPoint. So our mission is to what we call make state-of-the-art algorithms accessible and discoverable by everyone. So this general journey that we're seeing of as data has grown and as more and more machine learning and AI is actually starting to penetrate into the enterprise, into the different applications, discovering the right algorithms, discovering the right functions and models, and then actually being able to use them in the applications that you want to use becomes more and more important. So we're a company that was founded in 2014. We are headquartered in Seattle and now have a small office right about there. And we've raised about $13 million in funding. Recently did a Series A that was actually led by Google's AI fund. So this is a fund that's actually specialized in AI. So we've actually built out what is today the kind of the leading solution for finding, distributing, using, and scaling state-of-the-art algorithms. We started out with a marketplace, and the idea here was like, how are developers going to actually go out, find the nuggets of intelligence that they need, be able to consume it directly into their application in an easy way? And we did that at Algorithmia.com. We've scaled it to about today, we have about 55,000 developers that use that platform. Developers from across the globe can actually submit their models, algorithms, they can from different universities. Anybody can consume them through an actual API, and I'll show you how easy that is. We host today over 4,200 algorithms, functions, and models as services. So we've actually created a platform that today manages over infrastructure in a bunch of different clouds, over 4,200 services, all from one central point and location. And we have developers that call us from about 135 countries, which is kind of cool. So we've been lucky enough to be recognized by a couple of different publications and organizations. But at the core of it, what we've done is said, okay, at some point, developers are going to need to be able to consume this stuff, and there's a production environment that's required and a methodology that's required for doing it, and an architecture that's required to do that, and that's what we actually set out to build. So there's kind of three core problems that we identified and why we set out to build this company. The first one, which is there's a ton of data, and then there's a business logic that is required to be able to like apply that data to. So going out and finding the right neural net to do object detection, finding the right time series algorithm to do a certain type of analysis, finding the right natural language processing algorithm to be able to do some sort of text analysis pipeline is actually hard. And going out and finding those in an easy way and then consuming them is a problem. And how are people going to, as we move forward, every developer on Earth, there's about 13 million professional developers on Earth, how are they going to go ahead and build intelligent applications and find the pieces for that? So that's the first problem we go out and solve. The second one is, hey, that's already a hard problem, finding it. So finding it, finding the data scientists who can actually do it, the machine learning engineers who understand how to do it. Now, how do I actually put it into production? So our CTO kind of like, in defining the story, he says, hey, everybody talks about how TensorFlow is open source. Well, it happens to be that scaling it is not. So if you're actually going to go out and have, you think about you have an application running, and suddenly you want 2 million devices to connect to that application and be able to run it, there's a problem there. There's a production issue, and that's actually how something go. Another way of thinking about it is that anybody can stand up a web server, not too many people can run Reddit. Right? That's kind of like the analogy to think of. The third part is talent acquisition. There's actually a finite amount of people who can fulfill the role of data scientists and machine learning engineers. We're not going to, my background came from advanced analytics. We thought about this world of business intelligence. We were going to turn the entire globe into data analysts, and everybody was going to be data savvy. And that's actually completely possible. We're not going to turn the entire globe into data scientists and machine learning engineers. So what we need to do is we need to create methodologies so that data scientists and machine learning engineers actually are empowered to be able to affect the different parts of the organization and quickly expand their work, because their work is needed in every single line of business. Our HR systems are going to be powered by models and functions. Our CRM systems are going to be powered by this. Our customer service systems are going to be powered by machine learning models and data science systems. And so being able to do that is kind of part of what the problem that Algorithmia solves. So the core components of what our platform does, and I speak very quickly, so I apologize for that, is the first thing we do is we host algorithms as a service. We grab a piece of code, you push it into our platform, no matter what language it's written in and what requirements it requires. We can automatically containerize it. We can put a REST endpoint on it, and then we can deploy it onto a highly scalable and elastic compute infrastructure. The second thing is that once that is actually created, now this service exists, we register it. So now there's a discovery access. Anybody can come into the platform. Once they have our platform installed behind their firewall, they can start looking for it. And they say, hey, has somebody solved an image recognizer that finds a hot dog in images or not a hot dog? So I can go actually look for that in search and see if that's something that has already been exists and actually have it inside my thing. The third part is actually scale. So it's easy to, again, maybe wrap an API endpoint against the model and call it a couple times. What happens when I have 10 million API calls within a 2-hour period, and then an hour later, I have no calls, and then 3 hours later, I have 50 million API calls. A system has to be elastic to be able to grow and shrink itself to be able to deal with those up and down traffic, which is what most machine learning systems in production will actually deal with. And finally, I need to be able to monitor this, audit this, and secure this. Some of our biggest customers today are in regulated industries. That includes intelligence agencies, financial services, large pharmaceutical companies, and advanced manufacturing. They have regulators telling them, you are using these machine learning models. Who called it, at what time, what happened with it, when did that happen? Those are things that a proper machine learning system in production needs to be able to actually describe them. That's part of our infrastructure and what we provide. So with that said, I will have Ahmed actually drive the demo here. Let's see. Sorry, everything's very small. Yep. Should I disconnect the screen? No, you're good. There you go. And boom. And there you go. So, and I actually can't see, so I'm going to turn this a little bit there. So the first thing you're going to see is that I'm going to show you algorithmia.com. Which is our online version of this. Any of you can actually go to algorithmia.com today, sign up for free, play around with it, like everybody gets access to it. We actually grab everything you're gonna see here, we package it up, we put it behind your firewall, or on top of your own infrastructure. So this becomes a completely private environment. So the first thing you're gonna see is that we can actually explore the hundreds or thousands of algorithms that exist out there. Why this matters? At one point, companies are going to have to understand what the algorithmic and AI and machine learning assets exist in the organization, because there's value to understanding that this is something that your company's building up. And our vision is that 3 to 5 years from now, when you start seeing earnings calls, you're going to start hearing CFOs talking about their AI assets and the value that they're getting out of their AI assets, because they've just invested a couple $100 million in building those out. So I can go explore things like text analysis, which are the categories that we've created. And in this particular case, I'm going to go find maybe something like social sentiment analysis. So when I do sentiment analysis, which is kind of natural language processing 101, we saw a bunch of different options. We're a registry. All the options are there. We're not meant to be one specific algorithm. It's all the options inside inside an organization. They get to see, register everything. I get to search through it, see which one I would like to go. So in this case, social sentiment analysis, I particularly know that this was actually contributed by the AI lab at Georgia Tech to our platform. Really good on reviews and short social text, and so telling us, hey, the sentiment is positive or negative. So the first thing I can see is the latest version, how many people have called it. Everybody here familiar with GitHub, or almost everybody familiar with GitHub? Same kind of social, validation of the algorithms that are in the marketplace, but you can actually build that out inside your enterprise as well. When you suddenly have, you're a large organization, you have 20,000 developers, and a lot of people are using something, you have a better idea that that's good, that you might be able to bet on it for your own internal pipelines as well. So there's a description. Hey, this is how this sentiment algorithm works. This is how we use it. This is essentially the description. Think of it as the README. And then the most important part of our platform, which is what I call try it before you buy it. So you can actually execute any one of, remember, every single one of these algorithms, functions, and models is available as a service. So I can actually go ahead and execute it. So in this case, you can see that there's a piece of text, it's hitting run, and we're actually executing the code and doing it. What this allows is me as an application developer, or even a data scientist, I can actually go execute code, in this case, try my different data sets without actually writing a single line of code. And actually, what's happening behind the scenes every time Ahmed hits run is we're actually generating a container. We're putting the code in that container. We're deploying it to a worker node. we're computing the job, and we're bringing back the results. The total overhead of our system on a normal topology like AWS or Azure or Google Compute is under 15 milliseconds. So when we talk about scale and speed and production, that's the parameters that we're usually working with. So, and then once, now I've actually played around with the different, my data, I've checked and said, hey, you know what, this is what I want to consume. I easily can go and pick any single one of the libraries that I'm using it. We've already created kind of the SDK in every single one of the languages. Maybe I'm writing a Swift application, maybe I'm writing a Python application, copy paste that code into my application, and I'm ready to go. What's happening now is that from my application, I'm making an API call. I can call it once a second, 10,000 times a second, a million times a minute, and I'm actually completely scaling in and from behind this. So very quickly, I'm going to go create an algorithm so you see how easy this is to do. So he's going to actually go ahead and create a function. Again, and so you can see the quickness of deployment and how you can get in. So this is what an algorithm developer would do. Pick any language, create some there. Go ahead and create that. I can git clone this into my favorite IDE. So I just work in the normal IDE that I've always worked with. In this case, we have an online IDE. Ahmed's going to go ahead and create quickly a little function. Go deploy this. And now this is actually privately deployed on the compute cluster already live and working. That's all it took. So I can now actually go ahead and call this once a second, 10,000 times a second, a million times a minute. All the load balancers are already there. This function is actually completely scaling. And I can actually go ahead and use that. So I believe I only have a minute left. Perfect. So don't worry about it. So the idea really here is there's a last mile problem in productionizing machine learning and AI. And what it means is that as data scientists, machine learning engineers go and create new models, at some point that needs to end up in production. What we've done is we've created a platform, a framework, and an architecture to live between the application, which is that last mile, and all these developers who are actually creating these interesting models so that you can get to production quicker. And just remember that unless you get to production, there is no ROI. Right? Like you actually, unless you can get these things into production, unless you can actually grab the analytics, grab the data sources, produce something, and then deliver them to a customer, every investment, all that data cleansing, all that data collecting, all that data modeling you did is essentially throwaway. There's no ROI unless you get to production. So we're that last mile, and that's what we help different developers actually get to. Thank you very much for your time. I think I have some questions, actually.
How does it deploy?
So we're Kubernetes based, so we can go on OpenStack, we can be on Azure, we can be on Google Compute, we can be on Amazon.
So shippable, but you don't have a SaaS offering.
Yeah, so we have our online one, which any medium-sized, usually medium-sized companies who say, hey, we don't want to deal with any of the DevOps, we're just going to push code to your cloud service and you run it for us. And then for regulated environments, we come in and deploy inside the infrastructure, and inside the company, the developers are like, I don't want to deal with all the infrastructure, but it's already run by the infrastructure teams, completely secure, passing, it has to be a HIPAA compliant environment, et cetera, et cetera. Any questions? Good? Yeah?
Sorry, I'm thinking how training works on these models. Because what you've shown is like a really big model, but you've just shown the scoring.
Absolutely. You're completely great connection. So we are actually not a training platform. The whole point is that once you're done, you're going to do training and however you do training today. Maybe you're doing it on your laptop. Maybe you actually have a DGX box where you're doing neural nets. Yeah, and exactly. And so, except at a much larger scale. So now the training is up. You can actually put that in a continuously deployable function where the system gets retrained, pushes it into our platform, git push. We actually deploy it, run and monitor scale, and then you can have that circuit running over and over again. No, I'm sorry, I'm familiar with Flink, actually, I apologize. So, okay, no, so for the most part, we use Kubernetes, obviously Docker containers, and then a fully scheduler that we wrote from scratch to get to, the utilization levels that we get usually.
So how would a bandwidth work when you have to update the model? I mean, it's not just that, many models need to update based on the input data as they go.
Yeah, I think there's a series of models like contextual bandits, which are continuously being live updated. And what we've seen in general is that actually contextual bandits is a specific corner use case, at least for that type of model, where on a website like on Nordstrom.com, it's continuously being updated. But in a lot of cases, these models, especially for example in financial services, they have to go through a compliance. You can't be updating them live. They have to go through a compliance process. A lot of these in the life sciences, they have to go through a compliance process. So although there is a couple of scenarios of like continuously retraining where you.
If you're behind audience behavior, media, retraining constantly. But you're at a place where you can serialize your model and you have to get for the CEOs to sign it and deploy it before you can deploy it again.
Yeah. A lot of image recognition things, for example, like I might have like false positives on image recognition. What do you end up doing?
They're trained like neural networks in there, where other people have trained on vast quantities and then they deploy them. And I get to use their stuff with their deep learning training.
Yeah, so for example, like let's grab a TensorFlow model or Caffe model in like images. Somebody would have created it potentially, or you created it yourself. You pushed it into our platform. We're running it on GPUs. We're doing the inference part. We're an inference platform, which is the production side of things. Now, in that particular case, let's say that you have some bad examples, so like negative, some bad classifications. All of that can be stored into, for example, an S3 bucket, and then that can be pushed into a retraining process, and then the new model gets updated and to a new endpoint with a new API signature, and now you have the next one. So that continuous deployment cycle, we built multiple of those inside companies. 100% agree with it. Contextual bandit is actually a really interesting use case where you're updating within milliseconds the whole model, which doesn't work exactly well with this, but for everything else, this model works really well.